almost oily air.
Yeah,
We're diving into the tech that keeps those machines humming oil skimmers.
absolutely.
You've got stacks of research on this, so let's get into it.
Yeah.
And before you think it's just about cleaning up spills, trust me, there's way more to it.
Yeah, we're talking about how these workhorses impact the entire manufacturing process.
Okay.
Because when it comes to coolants in manufacturing, contamination is a huge issue that impacts everything from machine lifespan to the quality of the final product.
Okay, so before we get to the solutions, paint a picture of the problem. What exactly are we dealing with here?
Think of it like this. Manufacturing relies on coolants. They're essential for temperature control, lubrication, ensuring precision in various processes.
Right.
But over time, these coolants are contaminated with what we call tramp oil.
Cramp oil. It even sounds troublesome.
It is. And we're not just talking about a little bit of oil floating on the surface. This stuff gets everywhere, impacting the coolant's effectiveness and causing a whole host of problems.
All right, so the coolant's compromised. What happens? Give me the worst case scenario. What's the impact if we just ignore it?
Ignoring tramp oil is like neglecting regular maintenance on your car. Eventually, things will go wrong, and it'll likely be expensive.
Okay.
We're talking decreased coolant lifespan, reduced machining efficiency, increased tool wear, and even potential damage to the machines themselves.
So definitely not something you want to ignore, which is where our trusty oil skimmers come in. From your research, there seem to be a few different approaches. What are the main types of oil skimmers out there?
You're right, there isn't a one-size-fits-all solution. We've got three main types to cover: belt skimmers, disc skimmers, and tube skimmers. Let's start with the workhorse of the industry, the belt skimmers. Imagine a continuous loop of material, usually a belt, that passes over the surface of the coolant, picking up the oil like a giant lint roller.
So with belt skimmers, where does the collected oil go? Is it just redeposited somewhere else?
That's a great question. The oil is then scraped off the belt into a separate container for proper disposal or recycling.
Smart. Okay, that's belt skimmers. What about those situations where space is a constraint? I'm picturing a smaller operation, maybe not dealing with huge volumes of coolant.
You're thinking of disc skimmers. Instead of a belt, they use rotating discs that attract and lift the oil from the surface. They're incredibly efficient in smaller sumps or tanks where space is limited.
So disc skimmers are the compact solution, perfect for those tight spots. What about those really tricky situations, say oil pooling in hard-to-reach areas?
For those situations, we have tube skimmers.
Okay.
These utilize a narrow tube that skims the surface, and they're incredibly versatile. Think of them as the special forces of the oil skimming world.
Okay, tube skimmers. They sound almost surgical in their precision. So we've got our three main contenders, but with all these options, how do you know which skimmer is right for a particular manufacturing setup?
That's where things get really interesting. It's about understanding the specifics of your operation and matching them to the strengths of each skimmer type.
So what are some of the key factors to consider when choosing a skimmer? I imagine the type of coolant system is a big one.
Absolutely. Different systems have different flow rates, tank sizes, and even coolant compositions, all of which can impact skimmer performance. For instance, a high-volume machining operation with a large central coolant system will have different needs than a small shop with individual sumps on each machine.
It's about choosing the right tool for the job, just like any other aspect of manufacturing. Speaking of tools, what about the types of materials being machined? Does that factor into skimmer selection?
It certainly can. If you're dealing with materials that generate a lot of chips or fines, you'll need a skimmer that can handle that. Some skimmers have features like chip guards or sludge removal capabilities, which prevent clogging and ensure optimal performance.
Okay, so we've got coolant system type and the materials being machined. What other factors come into play?
Another critical consideration is the volume and type of tramp oil you're dealing with. If it's a small amount of light oil, a simple tube skimmer might be sufficient. But if you're dealing with a heavy oil load or a continuous influx of tramp oil, you might need a more robust solution, like a belt or disc skimmer with a high oil removal capacity.
And you mentioned earlier that different coolants can impact skimmer performance. What do you mean by that?
Well, coolants aren't just water. They often contain additives and chemicals that can affect the viscosity and surface tension of the fluid. This, in turn, can impact how effectively a skimmer can separate the oil.
So it's like choosing the right cutting tool based on the material's properties only in this case. We're matching the skimmer to the coolant's characteristics.
Precisely. And just like with cutting tools, there are manufacturers who specialize in oil skimmers.
That makes sense. Now let's talk about the benefits of using oil skimmers beyond just, well, skimming oil. I'm curious, what kind of impact can these systems have on a manufacturing operation as a whole?
The benefits are significant and wide-ranging. First and foremost, clean coolant is essential for maintaining the quality and consistency of your machined parts.
I can see how that's critical, but how does it translate to the bottom line? Give me the business case for oil skimmers.
When you have clean coolant, you reduce tool wear, which means you're replacing tools less frequently. That's a direct cost saving. You also minimize machine downtime due to coolant-related issues, which translates to increased productivity and higher output.
So it's not just about keeping things tidy, it's about optimizing the entire manufacturing process.
Exactly. And then there are the environmental benefits. By effectively removing tramp oil, you're reducing waste and minimizing the environmental impact of your operations.
Which is becoming increasingly important for businesses, both from a regulatory standpoint and a corporate responsibility perspective. Okay, we've covered the different types of skimmers and the factors to consider when choosing one. We've also touched on the benefits, which go way beyond just clean coolant. But there's one more thing I'm curious about.
Well, what's that?
We've talked a lot about the technical aspects of oil skimmers, but I'm wondering about the human element. What kind of impact do these systems have on the people working on the factory floor?
That's a crucial aspect that often gets overlooked. Clean coolant contributes to a healthier and safer work environment. With less tramp oil in the air, there's less risk of respiratory irritation or skin contact issues for workers.
So it's not just about protecting the machines, it's about protecting the people who operate them.
Absolutely. And a cleaner, healthier work environment can lead to increased worker satisfaction, reduced absenteeism, and even improved productivity.
It's fascinating how something as seemingly simple as clean coolant can have such a ripple effect throughout an entire operation. It impacts the quality of the products, the lifespan of the machines, the bottom line, and even the well-being of the workforce.
It really highlights the interconnectedness of a manufacturing ecosystem. Every element plays a role, and optimizing even one aspect, like coolant maintenance, can have a significant impact on the whole.
So for all the listeners out there who might be thinking, oil skimmers, that's not very exciting, hopefully this deep dive has shown that they're actually pretty critical pieces of equipment.
They really are. They're the unsung heroes of the manufacturing world, quietly working behind the scenes to keep things running smoothly, efficiently, and sustainably.
And with the increasing focus on automation and Industry 4.0, I imagine oil skimmers will continue to play an even more vital role in the future of manufacturing.
Absolutely. As manufacturing processes become more sophisticated and automated, maintaining optimal coolant conditions will be even more critical.
So there you have it, folks, a deep dive into the world of oil skimmers. We've covered the different types, the factors to consider when choosing one, the benefits that go way beyond just clean coolant, and even the impact these systems have on the people working on the factory floor.
Hopefully this deep dive has given you a new appreciation for these often overlooked pieces of equipment and the important role they play in modern manufacturing.
And who knows, maybe the next time you see an oil skimmer, you'll give it a little nod of appreciation for a job well done. Until next time, keep those machines running smoothly.